Hello, everyone, and welcome to our presentation today. My name is Dion Wiggins. I'm the CTO and one of the founders of Omniscien Technologies. I'm joined by Professor Philip Kuhn. He'll be speaking on a range of topics today collectively with me. We also have a special guest speaker who's pre-recorded because he's in Australia, and it's about 3 a.m. there right now. Dr. Joseph Sweeney, who's an industry topic called the future of work, and he works for a company called IBRS. So he'll be having his thoughts and sharing them with you. Today's topic is top 20 trends and predictions for AI and language processing in 2026 and beyond. And we have a very rich set of topics today, but we did something interesting. We thought we'd do an experiment this time around. So nearly every slide has been generated by AI. So what we did was we prepared the content we wanted to present, and we had AI draw the actual slide itself. And I have to say, I'm quite impressed, but it did get some wrong. So here's the first one it got wrong. We tried to do a title for it, and I became a rather good-looking black gentleman. Philip a lot younger, and Joe looks rather British. So I'm not sure what happened there. It picked up images from somewhere else. So it definitely can still make mistakes. So let's get down to business. We're going to be talking about 6 main topics today, and we're going to be going through at a very high speed. So we won't be going to any depth, but we will be making the full slide deck and the full recording available after the call, as well as a full transcript. So we'll be dealing with AI agents in the workplace, enterprise transformation and workflow automation, translation, transcription, multimodal, and language processing, infrastructure and compute futures, the year of digital sovereignty, 2026, and beyond the hype, the signals that actually matter once you get through all the hype. Now, when I talk about hype, there is a hell of a lot of it right now. And some of the biggest perpetrators of the hype are actually the big AI companies, Sam Altman and various other people, Elon Musk, Mark Zuckerberg. They're all pushing a hell of a lot of hype. And, it needs to come down to reality. So I'll pass this one over to Philip for the next piece.
Yeah. So this was like one of these famous things that kind of went viral earlier this year, where predictions were made about how AI is going to take over the world. It was kind of a story mostly rooted in like it's just going to get bigger and bigger, and by scaling alone, it's just going to be gigantic and it's going to be self-organizing. And then there's some kind of battle between China and the US, and at the end, the agents take over. So that is we're very skeptical about. The reality is that AI is a tool. It still has many fundamental flaws, and still important to view it as a tool so we control it. So the real risks are more in the area of privacy, data security, that it generates fake content, misinformation, and just also undermines education because everybody's just cheating on the exams.
Okay. So I used to work at a company called Gartner, and they had a thing called the hype cycle. But I recently redrew it for an article on LinkedIn that I published. So first of all, you have the big build up, the hype. So I've labeled that as the hill of BS build up. Then you get to the top, and it's peak of hype fatigue, and a lot of companies are at that peak now. Then you drop down into the landslide of reality setting in. And, a lot of the early adopters of AI have failed. And you see companies like Duolingo and many others that did very silly things with AI, and they got burned. Then you get the trough of POC purgatory, where we're just testing and trying things out forever. And people are calling this failures. But POCs are supposed to fail. They're supposed to succeed in some cases. So it's going through all of those different pieces. Then you have the other side, the crawl back to business value. And finally, when it works, everybody goes, yeah, it worked. So what? Cool. Next. Because by the time it gets there, it's just normal things. You might remember when Alexa came out, or Siri, and everyone was going, wow. Now today, it's just, it's not doing much, is it? Okay, comparatively. So things change. But along with that comes a lot of what we call AI experts, or so-called AI experts. A few weeks ago, they were doing blockchain, and before that, they were doing NFTs and various other things. So just be careful of those, especially on platforms like LinkedIn that claim they're experts. There's a lot of people who are just trying to play the game. The reality is there are a lot of good people out there, but there's a lot to learn. And even people like myself and Philip that live and breathe AI, we're learning every single day. We're making mistakes. We're learning from those mistakes and we're progressing. So that the information we share today may be outdated tomorrow in some context. Just keep that in mind as you learn, because the information changes constantly. So with that, I'm going to hand over to our recorder, Joe Sweeney, and he's going to speak for 4 or 5 minutes from Australia.
Hi, I'm Dr. Joseph Sweeney, Research Director here at IBRS. IBRS is a research and advisory think tank, and we deal predominantly with the C-suite and their direct reports on matters of technology and business investment. So we tend to be very, very practical when looking at future trends, and we do monitor them. When Dion asked me to talk about the trends for the coming year, I got a big grin on my face because I love talking about the future. But also I wanted to really call out in this as an opportunity that there's two types of next year projections. The ones that you'll be hearing most about are agentic AI and this future of this and future of that. They're very technology focused, and they're predominantly driven by vendor narratives. And the vendors will put these ideas into the mass media. People will read these, they'll get excited, and that will become the trend for the coming year. We don't do that. We do look at 10 and 15-year horizons for when certain technologies will become commoditized, because that's very predictable. The rise of generative AI was incredibly predictable over a very long period of time, and we got it within a couple of months because it's all economic. You can know based on the progress of a specific type of performance of computing to deliver a specific outcome of computing, of technology, you know when it's going to hit the market. But that's not the same with what the vendors are doing. That's not economic modeling, that's market modeling. So what we do instead is we analyze all of the questions that our clients are asking us, and we categorize them. We look at everything they're doing on our website, what research they're looking at, why they're looking at it, what their plans are, and we bring all of these signals together, which gives us really strong insights into what's actually going to happen at the coalface. What are these coalface challenges? So the big prediction for 2026, what's the big trend? It's a come to Jesus moment on the costs of technology, specifically AI. It's really one of the major drivers. And the reason for that is organizations for the last 20 years have been investing quite heavily and at an increasing rate into technology. But quietly, while that was happening, they've also been investing in consumption-based technology. And we're now at a point where a lot of the vendors are going, we've got AI, give us more money. We've got a legacy piece of technology, give us more money, otherwise we'll turn it off. And so this consumption model has meant that organizations are now really having to look at these costs and what are they getting from it. AI is, when it was first launched, the generative AI, I should say, when it was first launched, was a very false promise. It was launched too early in many ways, and prompt-based AIs, they don't actually deliver productivity. So the organizations recognize that, and then the vendors have responded with, no, now it's agentic AI, which is non-deterministic and all these funky words. Whether it is or not, it's a discussion model by model basis. But what generative AI does, what agentic AI does, is it dramatically increases the cost per business function of those AI services because it's spinning up many, many other iterations. And the come to Jesus moment that's happening right now with many organizations is they're looking at these, the IT departments are looking at this stuff and they're going, we can't float this easily to our management because they're going to say, where's the results? Where are the tangible economic benefits? And the problem is we're actually looking at some of these technologies completely the wrong way. The other trend that spins up from this is the notion of AI in platform as opposed to AI as platform. Let me explain. Probably about 90% of our clients in the mid-tier space, maybe just pushing up into the bigger enterprise space, their decisions are now being largely shaped by Salesforce or NetSuite or Zoho or whatever core platform systems we've got, Adobe, Canva. They're going to bake AI into the processes of our core systems, and we don't need to do much. We can wait until these services become available to us. In other words, we will be a consumer. Again, it takes us back to that consumption model, so you can see the linkage there. But we don't need to do much right now. Now, that is a trend which is really starting to take off. And we do see a lot of the core system vendors bolting on lots of AI services around the outside of their solutions, but increasingly we're seeing them baked into the solution. So that's the AI in platform. But the big trend that will be, I think, really creating some strong differentiation in the market, it's not new models, it's this idea of AI as platform. And that's where you have a highly architected platform that can use multiple models so that you can choose the most efficient model for the right task, not necessarily as agentic. A big part of this will be orchestration. In other words, taking a business workflow which is known and costable, very important, costable, and then placing AI appropriately at different locations on that workflow. So effectively, next generation business process re-engineering. Yep, we're back to the 80s, sorry. But that is really a very different architecture. And it's at the moment, it's probably going to be the larger organizations that will be adopting this approach, because it does require staffing, it does require a real knowledge of what your business is trying to achieve. Both of those are different, quite difficult issues right at the moment. But I do believe that as we commoditize that, probably late 26, early 27, that this will become a dominant model and probably will surpass all the excitement around agentic. We'll hear about agentic orchestration or AI orchestration. So that will be the next big trend. All of it comes back to being able to show a return on your investment, not just of AI, but of the entire tech stack. Because it is this come to Jesus moment in technology right now. Thank you.
Okay, great. So that was Joe Sweeney. He's been working with us for a long time, and I've known Joe for about 25 years now, and he's always been spot on the mark with his predictions and how he analyzes things. So next we're going to look at AI agents and the workplace. So one of the things that's interesting is we hear a lot about AI slop, cognitive decline, all that kind of thing. And, some people are predicting a surge of lazy thinking. And yeah, you're going to get it. Absolutely. That is going to happen. And they're going to, you get cognitive entropy, which, people sort of start losing the ability to think. But AI is an amplifier. Okay, so at the same time, people who put the effort in and use AI as a cognitive partner, so doing research, asking questions, reviewing the answer, things like that, not just simply taking the answer and saying, yeah, I'll use it as it is, and without even thinking, We've all heard these stories about people who follow their GPS and drive into a lake because the GPS said go straight ahead. These are the kinds of people that are on the left, where they just trust the technology and follow it. Okay, as opposed to people who question it, mine it, carry it on, have a full-blown, deeper research and understanding. So these people who can think better, decompose things, do multi-step analysis and critical evaluation, their results will be amplified substantially. On the other side, a lot of people's laziness will be amplified substantially. And really, that's what it's going to come down to. Okay, then we have work shifting. So a lot of work is shifting away from human initialize, and things are triggering, events are triggering. So, an engineering agent is, actively pulling requests during the night, remediating performance regressions, things like this. Work is going to become, in many areas, automated. And that's a really good thing. because it means that while humans can initiate some tasks, a lot of tasks will just be detected. An email arrives and it's an order for a product. Great, analyze what product it is, analyze the information you need from the customer in terms of color and size and things like that, process the order and send it out before your human agents even wake up. Happens overnight, in the middle of the night. And these things can happen continuously on an ongoing basis. Now, there's many different types of agents, engineering agents, support, operational, and many others. Some of them get interesting where they look at diagnosing and fixing things, but work is going to become continuous, not a series of manual human steps. Okay, now Philip and I were debating this one about an hour ago. This is actually quite interesting. So if you look at the lines, you can see, early on we had logistics agents and finance agents got a bit smarter. Now we have sales agents that are revising and updating CRM. We have some of those in our toolkit. Okay, but what you're getting to is the coordination threshold, where a lot of this is no longer needing humans to scale. Humans are still needed. They're not going away. But they're being refocused. But humans are linear. The more humans you have, you scale with those humans, whereas machines are not linear. They can exponentially grow. And so, crossing that threshold is something that at some point is simply irreversibly cannot go backwards. The output gap is just so wide and so far. Okay, now this one gets really interesting. Organizational memory becomes durable. Now, Philip and I were debating this, saying, how real is this? Because a lot of people have been talking about this. And you've got the old paradigm, people come and go from a company and they take knowledge with them. You train somebody and they leave, you've got to train their replacement. But with agents, they learn. And with the people that you have, they learn from the agents and the agents learn from the people. So Philip, what are your thoughts on this one?
Yeah, I mean, we see examples of that in kind of the field that we're very familiar with in translation, where, the accumulation of translation memories just creates a lot of, evidence that the agents then can learn from and then scale on top of that. So not just, the memory of all the translated text, but also the corrections that we've made to the translation systems. All that becomes kind of empowering for these models to then pick up from the experience of the humans.
Right. So you can see, day-to-day activities, the models themselves are learning, and a lot of the newer models are starting to progressively and continuously learn. They're not just static models anymore. And I'm not talking about RAG or anything like that. I'm talking about actually the models being updated. Then we have something even more interesting, leadership. And this becomes a negotiation between human intent overall and the actual system optimization. So, the human is more about strategic direction, ethics, exceptions, whereas the optimization is fully automated, system level rules, constraints, efficiencies, and it's those things that are taking over. So humans in many ways are going to move into governance and oversight roles in many, many cases. Okay, and that's where we head to next, where the human value is the checks and balances. And Philip, you had some thoughts earlier on this as well.
Yeah, so and also on the next slides, I'm gonna go into some detail on that. I think it's still important to not fully view this AI as fully automated systems that autonomously make decisions. They all require supervision. So if you just blindly trust what these systems are building, then you can get into trouble. Maybe show the next slide. So there are, for instance, all these famous cases of lawyers saying, oh, wait, it can do all the case research for me. Let it just generate kind of a legal brief. And then it just makes up case citations. And if you then submit that to a court, you get into deep trouble. So that's the risk. So if you think, oh, the law looks very beautiful, I trust it, you don't notice all the mistakes it makes. So it still requires oversight, coordination from a human. There still needs to be a human expert at the back that is smarter than the machine itself. So if you use it in that way, if you basically use it as here some headlines, as a replacement of paralegals that do research for you, that you can then check if it's correct, that actually is very, very enabling for higher productivity. So yeah, this is in a similar theme that we're building now these agent workflows either by kind of orchestrating them ourselves or by kind of having them more dynamically make decisions about which actions to carry out. These are at this point still fairly brittle workflows that require a lot of supervision and careful checking. So there's still a lot of questions that are currently being asked and need to be answered for these things to be really successful. And that really depends on every deployment specifically.
Right. So this was an interesting title. So as I mentioned earlier, we asked AI tools to generate the images and the slides for a lot of the presentation today. So we wrote the content and then said, right, make me images that represent this content. And they embellished the truth a little bit. I think civilization level is a bit sort of overly dramatic, but it's pretty important as well. So there is a digital divide that is being brought about by agents that is much more significant than any digital divide of the past. We talked about the speed things can be done and all those kinds of things. Well, if you can automate, you can do so much more, grow so much more, your economy is so much bigger, faster, meaner, cheaper, efficient, all those words. If you're stuck back in the older model, doing things manually, you can't move as fast. You can't even integrate with the fast people, right? And one of the things that's moving forward is agent to agent, where humans aren't even in the discussion for a lot of transactions. So this is inevitable. It is going to happen. The speed is what is up for debate. It may or may not happen in a big way next year, but the foundations will be set. And the performance gap is going to get bigger. The cost savings are going to be huge. The continuity advantage is, compounding. And overall, it is inevitable. Okay, there's going to be a lot of damage along the way. There's going to be a lot of people hurt, a lot of countries hurt. But it is going to happen, and we need to be in the right places at the right time to take advantage of it. Okay, so let's look at enterprise transformation. So by 2028, 90% of B2B buying is going to be agent-based, right? No human anywhere, just machines talking to each other, things that are needed. Okay, it's going to tie these together. Okay, procurement is being reprogrammed to say, I need something, go and find me the best deal. Negotiate the deal up and down and get the best deal for the company based on what you need, and then buy it without a human anywhere. Okay, so these are pretty significant. Okay, so there's going to be an operational shift from periodic correction, like we do now, like we look at our annual security policies and various other things and batches and manual checks, to just simply continuous. Okay, it's not autonomous, but it requires far fewer manual points of touch to actually keep it going. And that makes a huge difference. Humans are still going to be stepping in everywhere, but it's going to be human, not necessarily in the loop, but in the process in certain points. Then we move to the next one, which is from prescribing step by step to defining boundaries. So here's what you're allowed to work with. Go and work out the best way to do it. And it will find dynamic, practical workflows. Now, we see a lot of agents doing this already, making decisions on what to go and find, where to find it, how to get it. If something's not available, find a second path, second source, whatever it might be. Do it within the compliance and operational constraints, and do it automatically. Okay, these are all things that are happening right now within agents and within workflows. Okay, then we get the tempo. So we talked about this earlier a little bit, about the speed. So humans can't keep up. That's the reality. This automation is going to go hundreds of thousands of times faster than we can. If you look at banking today with stock trading, they're making transactions in milliseconds and making decisions about those transactions, selling it in 10 milliseconds and buying it 10 milliseconds later again. Right? All these kinds of things. So humans are going to be involved still, absolutely, in value judgments, exceptions, interpretation, and oversight, but less and less of the hands-on. So, fraud is happening rapidly today. It's greatly increasing, and we're entering an era where new kinds of fraud with AI being driving the fraud with phone calls where it's your daughter calling you, begging you for cash, or it's somebody, a politician, saying something that he didn't even say. All of these kinds of frauds are happening today, but they're getting faster and smarter and better all the time. And so we need tools that can detect them and work with them and process them faster and smarter and better all the time. Then we have structural risk. So this is where it gets interesting. So, the manual workflows are accumulating structural risk over time. They're slower response times, higher costs, reduced adaptability. They're very rigid. Whereas by the end of 2026, a lot of these gaps are going to become visible between the automated tasks and the compounding advantage that those automated tasks give us. So there's going to be reduced friction. There's going to be reduced issues. If a widget's not available here, find it somewhere else. Go and get it. You have these boundaries you can work within. If it happens at 3 in the morning, who cares? The machine will handle it while the manual people are sleeping. These are the kinds of things that are changing, and they're possible today. They're not fully widespread, but they're happening. And these are the companies that do this are going to have the advantages. Okay, then we have new business models. So if you add all this automation, of course, you've got brand new business models, end-to-end automation all over the place. There's no humans that are stopping things because it's 6 p.m. and we have to go home, or we don't have enough humans to process the full load today. We'll come back tomorrow. Okay, so with end-to-end automation, it becomes 24 hours, 7 days a week, 365 days a year, just continually operating and scaling. And when you have cloud, you can scale higher and higher. So start small. As your revenues and transactions go up, grow bigger automatically, not having to go and find humans, which are slower, expensive, and so on. Okay, then we have a little bit of reality. It is inevitable. The shift towards automated operation is what I mentioned earlier. But it's not inevitable that humans are gone. Humans are going to have new roles. Okay, they're changing. But once a sector demonstrates that continuous adjustment and lower costs are possible, there's no turning back. Everyone in that sector will move very, very quickly. Okay, and finally, automation becomes the mechanism that keeps enterprises aligned with real-world conditions. So today we're doing batch processes, we're taking inventory, we're bringing things in. Things happen around the world. They happen fast, and they're happening faster in business than ever before. Right? All these variables now can be monitored, and they've happened before. So models have the knowledge. The agents are looking at it, the workflow automation's there, the rule engines are there, and it's able to make decisions. Grab something here because in 3 months there's going to be a shortage. These types of things can be seen and forecast early, where the human manual processes don't see it because it was 6 months between orders. These are the kinds of things that can happen. So these are realistic things that are happening today, and they're happening across industries. This is not speculative. Okay, let's look at translation, transcription, multimodal, and language processing. Okay, language is beginning to become a commodity. Now, I'm very careful when I say that. It's not a commodity in the traditional sense. When I say language, I'm talking about language processing. So translation, interpreting, all of these kinds of things, there's still going to be humans in there for a very long time. But there is so much that can be done that does not need humans there, that just wasn't being processed before. We have a customer that receives invoices in about 50 languages. The machine translates them into one so that the back-end finance team can process them, right? Previously, they just couldn't handle those invoices in multiple languages. We have a customer in Germany. It's called UFA, where they're taking tens of thousands of videos, transcribing, translating, checking quality, and then publishing them to YouTube without a human in the middle. And they're getting new revenue streams from very much legacy content, 10 or 20 or even 30-year-old content. Now, to do it with humans, that wasn't viable. You're talking $1,000 or more an episode, whereas we're talking a tiny, tiny fraction of that, not even 1%, right, for the equivalent. So these are the things we're talking about going forward. Okay, so this is where we say it's becoming infrastructure, where day-to-day good enough quality, and it will continue to get better, means lots of things can be done. Yes, you'll still need humans for so many areas, but there'll be so many new areas where you don't need humans, where language can be processed. Good example of that most people are using today is meeting summaries. It's just now standard. It's a commodity. Okay, Philip.
Yeah, so one of the drivers of that is that the success that we have seen with large language models, so text models, is now slowly advanced into other modalities, speech and vision. And the interactions that people might want to have, not necessarily just with text, but also with speech. And the interesting thing about speech is also that there's always much more information in someone speaking than in the written word. So if you interact with a customer support chat agent on a text basis, it might not notice your frustration, but if it could listen to your speech, it does notice these things. So these are kind of the two things where the original text-based large language models slowly get advanced into speech modality and vision modality. Next slide. Yeah, so that's just the one directions. So if you add in to these models, speech, music, processing, so there's different things you might want to get out of the speech signal. So one is, you just want to hear what someone is saying. So it's still a communication media, but then there might also be other things that you want to get out of audio recordings. If you talk about music, if you talk about other kind of recordings, there's various informations you want to extract from that enables then all these kind of possible applications that you see on the right, up to kind of generative music production and things like that. Next slide. And then finally, the addition of video is also interesting because there's so many different things you want to get out of image and video. Famously, an image is worth 1,000 words. If you kind of narrow it down to kind of speech communication, yes, there's also a lot of information in the image, your facial expression, your mouth movements. All that is kind of important to really understand what the intent of the speaker is. So again, coming back to the kind of chat bot for customer support example, you need to pick up on, is the customer annoyed? Is the customer happy? Because you have to respond appropriately. If someone calls up and with an angry face and an angry voice says like, I bought this is crap, it doesn't work, then the response can be a chirpy voice. It just says, oh, I'm happy you're a customer. Let me help you. Because that just really kind of frustrates the customer then even more. So all this is kind of coming. Models that are sensitive, not just to what is being said, but how it's being said, and all the additional kind of visual information where that might be representative.
Okay, so this is where we get to something really interesting, and we're doing a lot of work in this space right now. So the knowledge stops being files and starts to become structured meaning. So we have a range of tools in our platform like Ask My Documents, where you can upload thousands and thousands of documents, or even a hard drive. And it uses knowledge graph and other technologies with embeddings and looks at structured representations and builds structured representations so that you can do cross-format retrieval, cross-department retrieval, cross-language retrieval even, and bring all this information back and render it back to the user in whatever form. It could be audio, video, text, whatever. I was playing with one of the tools recently from Google and says, hey, let's make a podcast for you out of your query. So I ran a prompt and said, tell me about digital sovereignty in this context. It says, great. And 2 minutes later, I had a 5-minute podcast with two people talking that in the middle you could actually interact with. Right? So these are the kinds of things where it's really starting to become structured meaning, and it's able to report on it, manipulate it, render it, so the multimodal effect kicks in, and it's bringing all this data together. Then you get human linguists, where this gets interesting. So I'm talking to a lot of language service providers right now, and these language service providers in the past were purely translation. Now, many of them have exceeded 50% of their business in doing data labeling and data preparation and getting data ready. And it's multimodal data. It's not just tagging text. It's going and taking photos and videos and various other things and working with that data. But they're preparing the data to teach machines or to drive different decisions within machines. And it's no different than having something like an automated autonomous car driver where it's learned by all the driver feedback. So it's getting all of this feedback and it's constantly learning to get better and better. Okay, then we get to low resource languages, and this is one of Philip's specialties. But basically it's starting to bring inclusivity in. Okay, low resource languages are getting new pressure points, but they're also getting new tools. So, for example, Meta just released a speech recognition model that they claim supports 1,600 languages. Now, that was just not even thought of possible even a year ago. Now, the quality may be up for debate, but the fact that they even have something is significant. Philip, do you have any thoughts in this area?
Yeah, it's still actually surprising how so far a lot of these language models are focused on the high resource languages. Clearly, I mean, there's economic incentives. There's where the money is and kind of the commercially relevant high resource languages. But yeah, there is so much more that needs to be done. People like to interact with these tools in their native language, and therefore expanding these models to cover more language, that is definitely a pressing issue. So if you look at, for instance, core machine translation, that went actually pretty far. Google Translate now supports over 200 languages, but these language models tend to still support maybe a dozen, maybe 24 languages. So there's still a lot to do to really have this inclusivity and to really then reach out to customers all over the world.
So were you surprised, Philip, when you saw the Meta speech recognition model with 1,600 languages?
Yeah, I mean, that's the kind of efforts that are being done. So it's always a bit unclear how good then the quality of these models are across these languages, but definitely the ambition to do that, to kind of move to so many languages, is kind of important. And yeah, this is a meta effort, comes more of the research division than product building, but that's where things have to go.
Right. Okay, so let's have a look at our infrastructure and compute futures. So the old paradigm was really based on short-term access. It was cyclical, uncertain, right? We now have this new paradigm: deliberate, multi-year planning, predictable access, continuous model training, continuous adaptation. Okay, that builds at a national level a digital capacity of stability and resilience that just wasn't there before, right? You can plan your supply chain, you can plan your various elements, and you can bring that all together and get that rolling forward very, very quickly. So, by tying that together, nations can shift from opportunistic access to deliberate multi-year planning for corporate energy cooling, specialized data centers, all of these kinds of things. They can plan in advance their growth, okay, and they can, bring that back to real world. Okay, so there's going to be centralized cloud, obviously, and we're seeing that today, but that's got a problem. It's got structural dependency. And a few weeks ago, we saw Cloudflare go out. And when Cloudflare went out, that one system processes every day or transports every day 20% of the world's internet traffic. So that was a significant outage. Now, the reality is, for a lot of the issues that Cloudflare had, people just hadn't spent a few $1,000s a year. And I'm talking people at the size of OpenAI, so companies that big. It's a few $1,000s a year to have redundancy. They just decided Cloudflare will never go down. They were dependent on it. And it did go down. It was a single point of failure from a simple bug in their software. Okay, so these things do happen. So we're going to see a lot more public and private systems rely on a handful of global providers. Their risk is going to increase, misconfiguration, outages, policy shifts, all that kind of thing. It's not currently presented as a catastrophe. It's, but it should be. And organizations have to respond to this, and you're going to start to see a lot of that happening, where organizations start to move beyond simple one risk places. So there's architectural independence as a practical requirement. okay, where things are broken up, public cloud, private cloud, a lot more on-premise and edge level. Our webinar that we had a couple of weeks ago, we talked a lot more on on-premise and edge level. So if you missed that, please go to our website and have a look. You'll be able to look at the slides and the video from last time. Then you have a lot more predictability. The current environment is very powerful, but way too rigid and way too fragile. Okay, we're going to see compute blocks emerge. Okay, so you've got the advanced block A, fabrication and governance, all of that's there. Okay, then you've got B and C. Energy abundance, and this is one thing that China's done really, really well. They are way ahead on the energy curve. They're producing, I think it's about 40 times more energy from memory, don't quote me on that, than America is, right? And it's cheap energy. But they did one thing smart. They looked at where they were producing energy across China, and this is over 15 years ago, and they started building out data centers where the energy is. It's a lot cheaper to run fiber than it is to run electrical cables. And as a result, they have huge data centers in the right places, low cost energy, and they're able to do things at an extremely powerful level. Whereas Europe and America are going to have an energy deficit and they have to build. Whereas China already has more than enough capacity. So, there's some interesting things happening in China in many areas. Okay, finally, physical resources as a limiting factor. So power is obviously a big one that I just mentioned, but cooling, keeping it cool. Now, you're seeing a lot of silly hype right now from Elon Musk and others. Oh, let's make data centers in space. I mean, it's silly stuff, right? The reality is it can be done on land and it can be done in the right places, but it has to be planned properly. And right now, the data center building in America is exceeding all building in America that isn't data center related. So just data centers alone. And it's just silliness because as IBM's CEO said just a few days ago, there's no way that they're going to get their return on investment. It's just not practical. So, you have this imbalance, there's these physical constraints, but they're charging ahead anyway. Okay, so we're going to look at digital sovereignty now. So the year of digital sovereignty is 2026. We're going to see, first of all, sovereignty metrics. Okay, we're going to look at some of the traditional ones, okay, and that's still going to be there, GDP, debt, all that kind of stuff. We're going to look at financial, all of that sort of stuff, but we're going to look at things like identity control, data residency, compute independence, model autonomy, and cloud exit feasibility. How can you move from one cloud to another? What are your scores? Okay, so I'm currently working on a book called The Digital Sovereignty Imperative, and it's looking at a lot of these metrics. That'll be out sometime next year, but it's just fascinating studying all of these angles and how that today there are no metrics, but it's definitely coming. So national digital sovereignty is going to become a big deal. The political economy of AI is shifting. There's a lot of things going on in America right now. Donald Trump announced yesterday he's going to be making some big AI policy announcements. Most of them are going to be around regulation or lack of regulation. There's, the US just announced recently the Genesis mission, which is pretty impressive, but pretty scary at the same time. So it's no longer about how fast we can adopt AI. The new question is how safely we can adopt it. And that's going to be very, very important. Now, there's going to be a lot of legal issues, and you see in Europe, the EU AI Act and all those kinds of things. There's going to be a lot of sovereignty stress testing. But there are big challenges, like the US Cloud Act is a big challenge. So China has something very similar, where in the US case, if you're an American company overseas, the US government can request the data of your customers, and you're not allowed to tell your customers. So these are the kinds of things that are pretty scary and pretty dangerous. Okay, and they cross jurisdictions. So, just be aware of a lot of these things. Okay, sovereign identity. This is one of the biggest issues. So identity is in the middle. Okay, and it governs everything you can do. You can lose your identity and lose access to everything. I know this personally because I lost my digital identity a few years ago when Google decided that I was a bad actor for commenting too fast on my own blogger posts, right? And it took me 3 weeks to get it back, and I had to fight a machine, no human anywhere. Israel just found out about it. Microsoft Azure shut down the Israeli military, a big division equivalent to the NSA in America, and kicked them out without any notice, just kicked them off because they eventually had too much pressure. They made a boardroom decision, and they shut that division out because of things that are going on in Israel and Gaza. Yeah. So, these things happen and you lose control. Your identity controls all of this. Okay. Now, nations with compute independence, that's where it gets interesting. Without it, you have a big problem. Okay. You've got all these kinds of issues. Okay. You're being controlled. You're becoming a rent paying country, right? You're not developing models. You've got data centers owned by big AI, even if you're in developed countries. So, for example, a lot of developed countries right now are doing deals with OpenAI and various others for billions of dollars, but they're actually setting them up as rent-paying futures. And then you're getting a few things that I'm not in big favor of, like, for example, OpenAI going into India and saying, hey, India, we're going to give everybody free access to ChatGPT for a year. Now, what does that do? Sounds great, giving everyone access for a year. But it just wiped out every single startup for AI in India. They can't compete with free. Now, in a year's time, when everyone's on the drug, of course, hey, now you have to pay. So it's an investment from OpenAI to basically wipe out the competition and get market share. There's no love here. This is all business. Okay. And that's where it gets pretty interesting. Okay. So you are going to get digital nation state platforms, regional specific AI platforms. So China's got theirs, for example. India's building out their own in a big way. You've got US, of course, pushing its things on many places around the world. And you also have hybrid ones as well. Okay, but there's a lot of competition and it's building up, and China's banking on that. So their GPUs now are shipping in over 40 countries, directly competing with NVIDIA, and their latest GPUs are on par with the top NVIDIA GPUs. So, the barrier is gone for the most part. They still have a lot of production sort of capacity issues compared to the West, but that's just a matter of time to solve. I mean, they're that confident that they're pretty much banned now NVIDIA out of China. So Donald Trump today says, oh, you can now sell NVIDIA back in China. We don't need to block you anymore. Yeah, well, it doesn't matter anymore. Time has passed and China has their own. So, it's moved on. But you're going to see these ecosystems of tax, customs, licensing, and public service delivery all around the world. And they'll be separate ecosystems. Okay. Now, this is a term that Gartner recently invented. Geopatriation. Now, I'm not a big fan of the term, but the meaning is interesting. So basically, a lot of companies and a lot of organizations are moving things back out of the cloud and back into their own data centers or their own sovereign countries. Now, be careful of sovereign clouds. Most of them are labels and are not reality because of, AWS is still governed by the Cloud Act, for example. So Microsoft recently admitted in a French court that if the American government asked for the data, they would have to hand it over. So these are things that you have to be aware of. This is why geopatriation is happening. People are moving things back into jurisdictions where they don't have control by another nation. Okay. We're seeing major movement begin to bring things home out of US-controlled data centers and bringing them back in. So moving away from foreign AI. Now, Mistral, ironically, the latest Mistral is very interesting. They have a chance to do something very, very important. So they're not Chinese, number one, and they're not American, number two. So if you can break away from those two platforms' constraints, you have something very special. And Mistral has some huge opportunities. They can become the equivalent of the Red Hat of AI and Gen AI models specifically. So they're in a very, very interesting position if they execute things properly right now. Um, we're seeing a parallel movement for declouding, so that's the geopatriation again, moving things back to automated orchestration in sovereign compute clusters, often shared. So it's ironic, when I first started, working, I was working on bureaus with big mainframes. We're sort of going back into that direction where somebody else owns the hardware and we just license a slice of it. Okay. Then the biggest challenge is the rent seeking. So you take in, $40 billion worth of data center and from OpenAI and you go, yay, this is wonderful. And for a year or two it is. And then suddenly they say, now you need to pay. Now you need to pay more. And now you need to pay more. And by the way, we're going to start putting ads in it as well, just to milk more money, and so on and so on. Right. So just be very careful if you're involved in this space of the rent seeking. Okay, and the last section before we go to questions, we'll probably run the presentation up to the end of the hour, and if anyone's got any questions, they can hang around at the end and ask them. We're just a little bit tight on time. Okay, so the systems that matter will not be visible. A lot of the systems are going to be hidden away behind the scenes, pipelines, monitoring, policy enforcement, integration work, all those kinds of things. And of course, the reliability layers. Sure, we'll see the chat GPTs of the world and we'll see, the Siris and those kinds of things. Everybody will see that. But the stuff that's doing the real hard work, think of it like global shipping. We don't see the ships, we just see the products when they arrive in the stores. And similar things going to happen here. Philip, do you have any thoughts on this one?
Sorry,
I guess not. I threw him under the bus. There we go.
No, I kind of got caught up in something else. Sorry.
No worries. We'll jump to the next one. Okay, so the advantage is going to shift to continuous operations. We talked about that earlier. Waiting for human cycles is going to be, in many business use cases, a thing of the past. It has to be automated cycles, continuously learning, not waiting to be fed data, continuously acting, not waiting for a human to trigger it. Okay, then we have constraints. So energy, compliance, data, safety, reliability, all of these things. So, there's a lot going on here, and these constraints are going to slow us down in a big way. If you don't have the energy to run your data centers, and some of these data centers are running, the level of small nations' energy consumption, they're absolutely insane. These things slow you down. The EU is being slowed down to some degree, and I'm actually not against that because of the EU AI Act. They're thinking about it a bit more, whereas America is saying, no regulations, let's go. And people are getting burned, IP is being stolen, many things are happening. So, it's not all good. It's not all bad either. Then we have system performance, okay? And this is going to start overtaking model performance. So right now we've been very focused on making bigger, better, smarter models. Okay, these are not the way to go, right? We've got benchmark saturation, benchmark for the sake of benchmarks. And in many cases, the benchmarks are just getting silly and they have to do new benchmarks because, it's just recall in many cases because a lot of these models are purely just predictive and statistical. So we're looking much more at system-centric views. Well-designed systems, and this is where a lot of humans are going to come in, higher skills, but highly designed, well-designed systems that can adapt quickly, that are observable, and that's key. The evaluation of discipline can be seen, workflow coherence, governed properly, so governance is tied in. Okay, all of these things are hard, but they're getting easier and they're getting smarter. Okay. Then you have the external realities, the narratives, the junk, the hype, right? Okay. If you look at the hype, and Philip talked about this with AGI and various things, it's way over the top. A lot of that's going to start disappearing, and you're going to start to see resilient outcomes. You're going to start to see facts. You're going to start to see all these pieces coming through. Now, a couple of weeks ago, we talked on the webinar about, all the failures and the MIT study that says 95% of all all AI doesn't deliver ROI in 6 months. Well, you know what? Most systems and most projects don't deliver ROI in 3 years. It's normal, right? But they pick a number and they hype it, right? But the reality is that means 5% are delivering ROI in 6 months. And that's incredible, especially when you put the numbers in. So we did some math, and about 1.8 million projects globally have delivered significant ROI in 6 months. Yet the noise is all about the failures, because there's about 36 million that failed. And a lot of them deserve to fail or were POCs to begin with. But the fact that you can have 1.8 million projects with huge early ROI within 6 months is a massive success. It just depends on which side of the coin you want to look at it. Okay. And then we're looking at the bubble. Now, I'm looking at the bubble in a different way. So yeah, you can look at the circular investment and all that kind of thing. But I'm looking at the operational bubble, okay, where we're going to get excess capacity in some things. We're going to not have enough in others. But there's a widening gap in the structural space. So getting it organized. Okay, what organizations can integrate things and bring together? So there's going to be signal collapse, right? And but it's not overall. How do I say this? It's not saturation, but you're going to have a lot of noise that's going to go away. You're going to see all that signal disappear. Okay. I don't think in the near term we're going to have the bubble people think we will in certain contexts. I think big AI has got some big bubble awakenings coming to them. But because of the number of successful projects that you just don't hear about, I think actually the bubble is going to have far less impact than people think. Sure, you're going to see big AI, and anyone who's dependent on ChatGPT or Google Gemini get hurt when the bubble pops, and it will pop. But there's a lot more stability below the bubble than most people realize. Okay, so the real projects are going to become clearer as the noise floor rises. Okay, you're going to see them. Their value is not rhetorical. Okay, it's observable, and you're going to see it. So 2026 is going to be the year that we actually see real results. And like I said at the beginning, it's going to be, yeah, so what? Because it's not exciting anymore. These things like Siri that were really cool when they first came out are nothings anymore. Siri's outdated now, right? It doesn't work as good as other tools. Simple as that. Okay, so we actually finished with 2 minutes to spare. So if you have any questions, please drop them in the chat, or you can email myself or Philip by mailing sales@omniscien.com. And we'd be happy to answer you later on. But if you've got questions now, and there's a lot of stuff here that we walked through, the slides will be available later. In addition to that, the recording and the transcription will be available. It'll probably take 1 or 2 days before we get it up online, but before the end of the week. So do we have any questions? Okay, we've got some messages coming in. Let's have a look. Okay, so okay, what changes do you think will AI do in academia? Philip, do you want to have a crack at that?
Yeah, that's a really interesting question. So because a lot of the AI tools that are out there can also be used for academic research, like finding related papers, summarizing research papers, figuring out, like, given this kind of set of dozens of papers, what's actually new, what's in common, hasn't been done, what has been done. There's a lot of excitement currently about, the role that it plays in research. And then also clearly in education, like how do we have to change our education system now that these tools are around? Just like when calculators came up and people used a calculator instead of adding up numbers in their head. So some skills are becoming more important and some skills might become less important.
Okay, and we had a question about linguist jobs. So I think linguists are going to have a really big role here. Not just in the tagging data. I think there is an ongoing job at the top end, no matter what, for really smart linguists. maybe the lesser skilled, more junior ones are going to find it harder, but I think that's going to happen in many spaces where AI is addressing things. And I think we've seen that in employment opportunities at entry level. I personally think that's a mistake because you're hollowing out companies. Um, but Philip, what do you think about linguist jobs in future? Where do you think they're going?
Yeah, I mean, this is the first year I heard that, yeah, the number of translators might actually go down. And so far, the idea was always you have higher productivity, so therefore you have more demand, and therefore you have more demand also for humans, even if, they're more productive and they get more done. So it all means that like everybody in this world, you probably need to kind of upgrade your skills. So there's still jobs for translators, for instance, in specialized domains, but general purpose where things just have to be good enough, that might actually go away. And that's true for everybody else. So if there is more productivity, then expertise comes even more premium.
Right. And what type of data prep jobs are going to be around? What do you think?
Ooh, that's a good, I mean, it's a very broad topic. Um, I think there's increasing finally awareness that the data that you feed into these models, sometimes it matters really very much what the quality of the data is. So not just throwing in every junk you have, no matter how bad it is going to be successful. So we've seen this increasingly that you get much more advantages of training on small sets of really clean and better data versus large sets of very noisy data. So yeah, being involved in that pipeline is probably important.
Okay, and another one just come in. Is there any synergy between video AI and language AI?
Yeah, I mean, up to the point that they're now using exactly the same model architecture. So even video is now using transformer models. I mean, these all used to be fields that are very, very different in the past. In video, you cared about, line detection, geometric models and rendering and all that. And now everything is going the same kind of generative AI training on lots of data kind of pipeline. So yeah, there's a lot of synergy and there's a lot of related questions you have, and it goes both ways. Sometimes you need image to help language, like I've talked about facial expressions that better understand what people are trying to say, but also the other way around. Language helps in generating images by kind of more clearly specifying what you actually want in the generation task.
Okay, and one from me. What do you think is the future beyond Transformer? What's coming next?
There is various talk about like state space models. I heard other models that are more inspired by how the brain really works. Yeah, we might be stuck at the moment a little bit with Transformer because a lot of things just gets optimized in the entire software stack towards them. So it's kind of really hard to make a change now. But there's definitely a lot of interesting ideas out there. So for instance, one of the fundamental problems of transformer model is that certain things like attention mechanism scales quadratic with the length of the sequence, and that gets very, very expensive. So doing away with those kind of things and just basically optimizing for speed and efficiencies, that might happen within the transformer paradigm. It might also be done quite differently in the future.
What about reasoning? How do you think that fits in?
Yeah, I mean that doesn't change the architecture of the model, it's just how you use it. And that's the whole reasoning wave and then the agent wave all go around like how do you actually use these tools. So at the end of the day, the GPT-5 model is just that. It's a model that has certain capabilities, but there are other things that maybe traditional computer science methods can do very well. So if it comes up like multiplying lots of numbers, maybe that's not something a language model should do. Then maybe that's sort of something that a traditional computer science algorithm should do. So balancing between them, and yeah, reasoning also involves a lot like feeding it the right information at the right time. So there's a lot of connection with kind of other existing components in a workflow that are, yeah, still very difficult to then really figure out for every particular use case what you have to do.
Right. Okay. And we've got a couple more come in. So you mentioned that the language model should be or is already learning. I assume this process should continue indefinitely, considering automatic translation. How can we secure confidential data in corrected translations are to be returned to the LLM? Do you see a place for an intermediate process anonymizing, or are we forced to use separate dedicated LLM storage?
There's a lot in that question. So yeah, so
There is. That's a big one.
I mean, the situation already right now is that you have these large pre-trained models, and they get built even by the big companies only like once or twice a year, and then all the interesting stuff comes afterwards. And there's a lot of modularity there, so you can adapt the models in many different directions. Sometimes you can then add these modifications together, and sometimes not. Yeah, any data you feed into, and if it's trained on your company's data, you clearly want to have those modifications separate from, any kind of model that's publicly available, and you have to be very careful about that. No, there's no like data leakage by kind of querying the model and then revealing information that you don't want it to reveal. Yeah, so there's a lot of modularity, sorry, in the how you use these models.
Right, and I'll just add to that. A lot of the models, Mistral, DeepSeek, Qwen, Llama, etc., right, are specifically designed to allow you to extend or to extrapolate data and make smaller models from refactoring and things like that. So the future in many ways is not large language models, it's small specialized language models that are really focused on tasks. And just a few days ago, DeepSeek released a specialized language model specifically to do very, very complicated math, as an example. Now you can then pair that with various other models so when the model needs math, it can call, different layers of experts or different layers of models and do that work. But just adding to the final answer here, bringing it back home, this is where a lot of these models are downloadable. And they can be adapted with relative ease now for customers to keep them up to date. But what's going to be interesting, and this is where I don't see a definitive pattern yet, is do we have to run for 1,000 customers, 1,000 models and keep them learning independently? Or is there something that we can put around it as a layer in the middle? So I've yet to see the answer to that one, but maybe Philip, you have.
Yeah, I don't have any kind of further comment to what I said before. I did want to make a comment on what you said earlier about the bubble. So there's clearly kind of an AI bubble in kind of valuation of companies and kind of dreams of $1 trillion companies.
Oh,
and
yes.
it's all very reminiscent of we're old enough to have lived through the internet bubble, which was also a tremendous bubble, which ended in like complete collapse of various companies and stocks. But at the end of the day, I mean, the internet turned out to be somewhat useful and it's been around. And I think there's a very similar situation with AI, that maybe OpenAI will go out of business in a year or two, but AI will stick around.
Absolutely. And I think that's a great place to close on. So thank you very much for your time today, everyone. This recording will be available in a couple of days. The slides will be available too, and so will the transcription. Thanks for your time. We look forward to seeing you next year on our first webinar in January. Until then, if you want to contact us and learn more, I'm dion.wiggins@omniscien.com. You can also reach me at sales and Philip at sales. They'll both arrive and the sales team will share the messages on. Thank you very much for your time again, and we hope you all have a great new year. Okay, bye for now.